Hello everyone. Today we'll be solving questions on CAD, questions on projections of line specifically. So let us go ahead with it without wasting any more time. Let's start. The top view of PQ of a straight line is 70 mm and makes an angle of 60 degree with the XY line. So the top view of PQ of a straight line is 70 mm. That means the top view length TVL is 70 mm. So it is the TVL is 70 mm given to us, and it makes an angle of 60 degree, which is beta. So beta is 60 degree. The NQ is 10 mm in front of VP and 30 mm above VP. So Q is 10 mm in front of VP, and so it means 10 mm in front of VP and 30 mm above HP. So 30 mm above HP. Okay, then what's given is the distances between the distance of PQ about the HP is 45 mm. So the distance of the P and Q, that means P minus Q, is 45 mm in the HP. Great, got it. So now what we need to do, we need to draw the projection and determine its true length, true inclination with HP and VP. So let's get started and do it in SolidWorks. Okay. So let me frame it. So first thing what we need to do is draw the XY line. And it is of the point thickness of 0.5, yes. So we need to do it from here to here, 0.5 thickness, center of the sheet. Yeah. And then we need to draw the point Q. Before that, yeah. So let us draw the point Q that has a thickness of 0.18 mm from here to up here, and then another line from here to here. So this point has a length of what is given in the question. It is 30 mm above HP. So it is 30 mm above HP, and this it is 10 mm in front of VP. That is what is given to us. Okay. Next thing what we need to do is let us annotate it. Now we'll annotate later. By the way, I'll just put the annotation for this point. It is how much? This is Q dash. And this point is Q. Okay, fine. We are done with this thing. Now what we need to do is we need to draw a parallel line to XY plane. So we go ahead here and here. We have drawn a parallel line up, as well as we'll do the same thing down below. We go till here and till here. Once this is done, we'll go ahead with the question. So what it says is we have the top view length as how much? 70 mm. So we draw a 70 mm line, and we also have the beta. It is at 60 degrees. So we draw a 70 mm line with an angle 60 degrees. So we have it a 70 degree line. Sorry, 70 mm line. So this is 70 mm. And the angle is, as given in the question, is 60 degrees. Okay, this is the top view length, and it is the darkest line, so 2 mm thickness, and where this ends we get the locus point of B, that is a construction line, so 0.18 thickness. Yep, so it intersects here. So next thing what we do is another detail that is given to us, that is the distance P minus Q. Just a minute, I will enable something. Yeah. Okay. Okay, as you can see this thing here, so this is point Q dash. So, and P dash, the distance given is 45 mm. So we will draw a parallel line to this, which is at a distance of 45 mm. So let us draw a line parallel to XY plane, and a distance between this and this is 45 mm. 45 mm. It is given in the question. So after doing all this, we get down below here. We take a radius thing. We take a center point arc from point Q till this line intersection, and we intersect it at this point. So from this intersection point, we need to go till this locus of B. So let us draw this line from here to here. So what we get here is the point P1 dash. So let us draw the line, and the line thickness is 0.35. Line thickness from here to here. Okay, so after this thing, we have this line. This is the top, this is the true length. And then what we do is from this point, we take a parallel line at the top. From this point till here at 90 degrees, wherever it is intersecting, that is a construction line, so 0.18 mm. Yeah, this line, it is intersecting here. So it should be 0.35 mm. So point from here to here, we just join the line, and this line should have a thickness of 2 mm. So we are almost done with it, with this question. So let us label this point. This point is P dash. This point is P1 dash. And then we have this point, which is P. And yeah, one more thing that is remaining is we have to, from this point to this point, we take the radius and we cut an arc here, and from where we have cut the arc, from there we drop a perpendicular to this locus of B point, and this thickness, this is also a thin line, this one is a thin line, so this point is going to be a P2. So let us annotate it. It is a point P2. So we are done with it. No more construction remaining except for joining these two lines, that is to join Q and P2. This is the true length, so it has a thickness of 0.35 mm. So let us start with the dimensioning. So first thing is this angle, it is 32.74, which I got, and then after is this one, that is 52.13, and then this dimensioning, this angle, this line and this line. Oh, sorry, not that one. That line and this line. This is 46.76. So after doing that, we need to take the length of this line, the length of this line. How do I do that? Yep, I do this, select this line and get it. It is 83.22 mm, and the above line too, I get this as 57.01 mm. And let us go with the next question what we have. So here is coming up the next question. The question says a line AB measuring 70 mm has its end A 15 mm in front of VP and 20 mm above HP. So 15 mm in front of VP and 20 mm above HP. Noted. And the other end B is 60 mm in front of VP and 50 mm above HP. 60 mm in front of VP, 50 mm above HP. Done. The line AB is measuring 70 mm. So 70 mm is the true length. Fine. We have to find all the 8 parameters. So let us start plotting this. Opening SolidWorks. Fine. So let's start. Thing we need to do is first thing first. 0.5 mm XY line from here to here. Is it? Yep. Then what we need to do, we need to plot what is given to us. That is A. Point A is how much? It is 15 mm in front of, wait, yeah, 15 mm in front of VP and 20 mm above HP. Okay, so 15 mm and 20 mm is what I need to keep in mind. So on doing that, let us put the dimensions for this. This is 20 and this one is 15. So done with this. And after that, we have got point A. Now, as usual, when you get the point A, draw this parallel line. Same, do it down. When done down, so we have got these 2 points. Now, it's also mentioned in the question about the point B. So it is told that B is 60 mm in front of VP. So 60 mm in front of VP means we have to draw a line over here that is at a distance of 60 mm from this XY line. Is it XY line? Yes. So this thing is 60 mm. It is also given in the question that we have the point B is 50 mm above HP. Right, 50 mm above HP. So this line is 50 mm above this XY line. So 50 mm. Yeah. So this thing is done. And then we have the point from A to this thing. The true length is 70 mm. So take a point L here. And no, we have to take an arc of length 70. Right. So an arc from here and it should intersect here. And the smart dimension for this one to this one Why isn't the smart dimension coming for this? Let me see once again, please. From this point, okay. So what I have to do now is from this point to this point. No, not that. Can't I put smart dimensions for this? Yes, got it. It should be 70. So when 70 is done, let me extend this arc here. Wait, what's happening? Okay, so it intersects here. So I draw a line from here to this point. Let me zoom in a bit. Why am I not getting exactly 70? It's fine anyways. Let me go to the exact preciseness. Okay, now this point is 70 mm, right? Okay, so we got it up. We do the same thing down below from here to here. First, we have to draw the center point arc. That is nothing but take a compass and cut an arc of what length? 70 mm. This thing is 70. So once we get 70, we have to draw the line from this point to this point. Yep. So this is done. Then after this, I would prefer to erase this arc. Okay, so arc is erased. We have got these two true lengths. So we know that true length has a thickness of 0.35 mm. We do it for both of them. Now comes the main part. So this is what I've done till now is the given data. After this, what we do is take a compass from this point to this point. Okay, and we cut the arc over here, cut an arc. After cutting an arc, we draw a line from this point to this point here, straight perpendicular line. Same thing we do again for here. Uh, Wait, sorry. Uh, Center point arc of radius from here to here, and we cut an arc here. I am really sorry. This is not the way you do it. I'll just erase this thing. There is slight correction. So what we do first is we drop a line from this point to this point, and from here we take an arc. So that was the mistake I did. I apologize for that. This is the radius, and wait, yeah, we cut an arc here. So this is the point we get. So we join these two lines. So from here to here, this is the length we get. This is the top view length. So 0.35. No, it is 2 mm. This thing is 2 mm. And then after that, we similarly do it for this point. We take a line from We take a line from here to here. Yeah, from there till here, and then from this point L, we do the center point arc from here to here. I put the point and cut it here. So this is the point called B dash. So draw the line from here to here, and this line is, wait, I've done a little mistake in drawing the line from this point to this point. Yep, done. So this is 2 mm line. Let us annotate, and this is all the question expects of us. Just for confirmation, we can draw a line from here to here, from here to here. I guess so, but yeah, I drew the line. So this is what we got. Let us do the dimensioning and the annotation. So I will do the dimensioning first. From this is this angle, and so this much. What did I get? Yeah. Now we'll do the same thing down below. This one and this line. Let us put the angles. Angle done. And then we need to take the length of this line and also the length 70 mm. Same thing up here. Same thing goes for this line too. So after doing this, we need to do the distance between end projections. So the distance between this point and this line, wait, the distance from this point and this line, 44.77 is what I got. Is this thing right? Hopefully it is right. 53 degrees, 25, 34, 14, 46. Next thing what I would like to do is I would select all the dimensions and just format them. So this is how the final result looks like. You can have a look. The angle here is 25 degrees, 34 degrees. We have the front view length as 54 mm and the true length as 70 mm. Front view length is, sorry, top view length is 64 mm. And this is the final diagram we got. Okay, let's move ahead to the next question. Let's go to the next question. So next question coming right in front of you. The front view of a 90 mm long line which is inclined at 45 degree to the XY line measures 65 mm and A is 15 mm above the XY line and is in VP. Draw the projections of the line and find its inclination with VP and HP. Okay. So the data given is the true length of the line, that is 90 mm, and it is inclined at 45 degrees. True length done. Then that is 45 degrees the theta. Then the front view length, which is given as 65 mm over here, and the end A is 15 mm above the XY line. So it will come in VP. Okay, fine. So let us do this in SolidWorks. Okay, as usual, we start with the XY line. What is this? Wait a minute. Yeah. Okay. After doing this, we have given to us A is 15 mm above HP. That is above XY line. That is a question. So from here, I draw over here, and this thing is 15 mm. 1515. Yep. So this thing is done. So next thing, as usual, our basics. Draw here and then here. So done with this. So we have got a point A dash. Next thing we do is we know that we have to draw a 90 mm line, which is at 45 degrees. So this line is 90 mm and it is at 45 degrees. 45 degrees. So 90 mm line at 45 degrees is what we have. And also given we have the front view length. Okay, when this is a point B1 dash. So we draw the locus of V. So from here, we need to cut an arc again. From here, I don't know what is the thing. From here, oh my gosh, what is happening? Yeah, we cut an arc, and the arc and the radius is 65 mm. Let me zoom in a bit. So it is cutting the arc here. So I will draw a line from here to this point. Kind of satisfied, not satisfied. Yeah, this seems better. Okay, I will delete this arc. This is 65 mm from this point. Okay, so we are done till this one. Let me just put the dimensions for this. Hmm, why does it no? Okay. Yes, so this is what we have got. Next. Okay, next thing, what we do is we would drop an arc, sorry, drop a perpendicular from this point till here. Okay, which, yeah, to this point, and after drawing till here, we would need to take a radius from here to here and draw an arc somewhere till here. Okay, after doing that, what we do is we drop a perpendicular from this point to here. It is in perpendicular from this point till here. And wherever it is intersecting, that is going to be a locus of V. So let us trim this from this point here to here. And next is really simple. Then we join this line and this line. And after that, we take a center point arc from point A to here, center point arc with radius from here to here, and cut an arc here. Okay, we trim this part, draw a line from here to here, then again trim this part, and then join this and this. So we are done with it. So this is the true length. So 2 mm, this is going to be 2 mm. This is also 2 mm. This one is going to be 0.35. This one is going to be 0.35. Okay, so let me do the labeling. Let me annotate the points. So this point over here is A dash. Then over here it is A. And after that we have a point over here that is called B. This is B2. Here we have B1 dash. Here it is point B dash. Okay, this is the annotations. Let's do the dimensioning. This one and this line. Why does it select here? 43.81. Then this line and this line. 78. Wait, this is the line I would prefer to do first. My mouse isn't working well. What's going on? Yeah. Okay, so after that, let me do the dimensioning for this one and this one. This line and this line. And I would to take the length of this line, that is 90. Cool. And then the dimensions for this line, that is 63. Okay, done. All of them done. So this is the final diagram we have. So let me tell you the things. So we have the true length as 90 mm, as you can see here. True length is 90 mm. Then the top view length is 64. Front view length is 65. And true length is 90 again. 45 degrees is the theta. Alpha is 78. 44 degrees is phi and 78 degrees is beta. One more thing that remains is the distance between the end projections. That is 13.23. Wait, let me do that thing again. Yes. So we are done with this question. Let's move ahead with the next question. Question coming right in front of you. The top view of line PQ is 70 mm and front view is 60 mm, and the NQ is nearer to both HP and VP and is 15 mm above HP and 20 mm in front of VP. Draw the projections if the distance between the end projector is 50 mm. So given the front view length is 60 mm, top view length 70 mm, point Q is 15 mm above HP, 20 mm in front of VP, and distance between end projections is 50 mm. So let's go to SolidWorks and start solving. New sheet, we have it here. Let us start with our basics. XY line, starting from here to here, and then our construction line, point Q. So what is given for point Q? It is, let me check, 15 mm above HP. 50 mm above HP. So this one is going to be 15, and then 20, because it is given 20 mm in front of VP. So after we get that, as a tradition, what we do is take this point, bring it here, parallel, done. And after that, take this point here, get it here, and till here. So we are done with this. The next thing which I would love to do is the DBP. It's my favorite questions. So we draw a perpendicular line, and the distance between these two is from here to here, as given to us, is how much? It is given to us as 50 m, 50. Let me extend this because we might need some more of it. Can't I extend it? Yeah, extend like that, extend like this. Okay, what is going on here? Did I mess up something? Okay, so we are done with the DBP. Now, simple the front view length. We take a point here, from here, point here. We have to take the center point arc from here to here, and then we cut it here. And the radius of this is going to be how much? It is given as 60. So 60 mm. So we have put it as 60, then we draw a line from here to here. Should be exactly 60. Okay, so we are done with that, and then we do the same thing down here. It is given that this thing is 70 mm. Fine. So from here to here, we draw cut an arc, and this thing is 70 mm. This one, like this one, is 70 mm. Not that, we have this one, 70. This moving. So we have got it as 70 mm. So the point intersects here. So I will draw a line from here to here, hoping that this is 70. Yep. So after this being done, we have got the front view length, top view length. Just a second, let me look at previous question. Okay. Yeah. Front view length and top view length both are 2 mm. After doing this, we have to draw the locus of point B. So from this point, come left here until here. Haven't I drawn it properly? But okay. Same thing we do it up. Locus of B. After doing that, it is quite simple. So from this point, we have to draw a center point up. I would erase this one to avoid confusion. Erase this, erase this. Okay. So take a compass, measure this one. It would come 70. Cut an arc here. So after cutting an arc there, yes, from this point, go straight up to the locus of B and this, and then join these 2 points. Join them correctly. How do you join them exactly? Yep, done. And same thing, we have to do it for the above line. So from here to here, this radius, we would cut an arc here, and then from here we would draw a perpendicular to the locus of B down here, and then join this line, and this line. Hmm, Are they joined? No. From this point to this point. And this is our two length, so select these two and we will put this as 0.35. So we are done with this one. Let us do the annotation and the dimension. I will do the dimension first. So this is what was given to us 70 mm for 60. This one I got it as 77.48. This one 77.46. Good. Then after that, angles remain. This one and this one, 23.35. What did I just do? This one and this. So this is the final thing what we have. This point A dash, and this is point A. VPHPXY line, I hope you can label it. I'm just explaining how it is done. Anyways, let me label it too. Give me a moment of time. So let us annotate. This is our point A dash. Yep. And this is a point A. This is our point B dash. This is our point B1 dash. And then this is our point B2. This is our point. Wait. Okay. Over here, our point B. Yeah, so this is the points and lines. Let's go to the next question. Yeah, let us go to the next question. That is fifth one. A line has its end, a line has its end A 15 mm above HP and 10 mm in front of VP. So this is the given. The end B is 55 mm above HP, okay. and the line is inclined at 30 degree to HP. The distance between the end projections is 50 mm. DBEP is 50 mm. And there's theta somewhere. Yeah, the line is inclined at 30 degrees. Okay, which line is this? Which mm? The end B is 55 mm above HB and the line. Okay, the exact line. So it is at 30 degrees. So there is the true length is inclined at 30 mm, 30 degrees. So we have to draw the projections and find it out. So let's start with it. Draw the XY line. Draw the XY line. Then point A itself, right? So it would be from here to here. Same thing down. And also given we have the point B above this thing, so I will draw the line right now itself. Okay, fine. I will do this one first. I will put the dimension for this. It is given as 15 mm above HP. So 15 mm above HP and 10 mm below HP. So this one is 10. Yeah, this thing is done. So after this, what we have to do is, as given in the question, B is 55 mm above the XY line. So we draw a line. What have I done here? So we draw a line, and this line is 55 mm above the XY line. So this is the XY line. So after doing that, it is also given, we have DBEP given in the question. So I would take advantage of that. So because DB is given, I would draw a line like this. So and dimension it. So it is this one and this. Wait, what's happening? Okay, I was dimensioning with the dimensioning name. Okay, so DBP given to us, it is how much? 50 mm. Yeah, 50 mm. So we have easily got the point, which point, the point is B dash. That would go from here to here. Okay, and after that, we also can get the point because we have given theta is 30 degrees for the true length line. Okay, we draw one more line. I'll change the thickness later, so I'll go with the default thickness. What is here? So I will draw this line till here, wherever it goes. But the thing which I know is it is at 30 degrees because it is given to us. And before that, the thing which we usually do, I forgot that, a ritual, I would say, is this one. We have done that. And same thing down below here. We do this one and then this. Yup, done. Cool enough. Now this thing is 30 degrees as given in the question. Let me check with the question. Yeah, it is 30 degrees. So I will do this one and this at 30 degrees. Yeah, So it is a 30, it is intersecting here. So this is our point B1 dash, and this is B dash. So B dash I've dropped it down. So from here, same thing. I would drop a line down from here. So the next thing which I would do is, so from here I would drop a line from this point down here. No, not there. Sorry. From this point L till here. And from here to cut an arc as usual. From here to here and cut an arc. So it is intersecting here. I've got the locus of V point. So from there till here and till here, locus of V I've done. After doing locus of V, I will join this line from this point to this point. Done. And then from here I have to do another center point R, taking from point A dash to wait a second. Okay, then we draw the center point arc from here. I was facing a little issue with that. Oh my god. Yeah, this is the point. Then I trim this, draw a line from this point till where it intersects here. Yeah, and this point from here till the line. So this is the true length. We got that. So let me do the, what you say? This thing is 2 mm. This thing is 2 mm and this one is 0.35. This one is also 0.35. Yes, so we are done with this. And yeah, so after that, let's do the dimensioning. So dimensioning this one and this one, 38 is what I. Then this one. Oh, okay, yeah. Then on doing a dimension for this one and this one, I get 36.71. And then this line and this 43.69. Did it change? Yeah. And then after that, I have to do the dimensions for this. Okay. Dimensions for this. Done. Dimension for this. Done. And I have to trim this part. And dimension for this line is 80 mm. Wow. Okay, fixing the leaders, we have putting everything as none, leaders as this one and this option. Okay, so we are done with this question. As you can see, theta is 30 degrees, beta is 30 theta, and phi is 37 degrees. Then we have beta is 44 degrees, alpha 39, true length being 80 mm, and the front view length is 64, and top view length is 69 mm. DVP is 50 mm. So that is the end of this question. Let's go to the next question. Here is our next question. The DBEP through the endpoints of a line AB is 40 mm. The end A is 20 mm above HP and 15 mm in front of VP. The end B is 45 mm in front of VP. The line AB appears 50 mm long in front view. Complete the projection, find the true length of the line with HP and VP. Cool enough. So these are the given data. You can have a note DVP 40, A and B is given. Fine. Let's go ahead and do it. Back to SolidWorks. Let's have a XY line 0.5 from here to here. And after XY line done, let us plot point A from here, from this line to here, and then from here to here, and put the dimensions. What is A? A is 20 mm above HP, and then we have 15 mm in front of VP. Yeah, this thing is done. Now, as usual, custom, put this thing parallel to this and over here. Next thing from this point, from here to here. Oh wait, it went a little wrong. From here to here and back here. So we are done with this. Let's see. Point B is 45 mm in front of VP. So we draw one more line here. That is going to be locus of V. Wait. Here. Yeah. And this line, as said to us, is how much? 45 mm in front of VP. So we are done with this one. Next thing what is given to us is DVP is 40. Wow, cool. That is one of my favorite things. So we do this one and DVP is 50 mm. Then the next thing we do, we join these 2 points over here and we got this thing that was really cool. Okay, then what is the next thing given to us? We have the front view length is 50 mm. Front view length is 50 mm. So here we have to take an arc from this point to here to here. This thing given to us is 50 mm. 50. It goes there. Are you sure of that? Okay, I'm really sorry. I forgot to take the dimension, the distance between end projectors. Distance between end projector given to us is 40. Yeah, and this point would come and lie here. Okay, and this intersection, let us draw a line from this intersecting point till here, and that is 50. Okay, then I would draw the locus of V from here to here and then back to here. Cool, we have got a locus of V. Then it is simple enough from here. For easiness, I will erase this one and this one. One second. Okay, then the thing we do is we draw a center point arc taking from here to here as the radius, and we cut an arc here, and after we cut an arc there, I will trim this part, draw a line from here and down below to the locus of P. Same thing I would do here. That is, I would take a center point arc from here to here, draw it till here, draw a line from here till here, and then I would join this line and this line. Wait, I would join from here, okay, from there to this point. Yeah, same thing I would do down. That is, I would join here to here. And next thing is I would adjust the thickness. These two are 2 mm lines. Yep, we are done with this question too. That is how simple it was. Let us do the dimensioning. Yeah, here to here. This dimension is also done. Done with this dimensioning, and also this one now. Let's do the same thing up here. So let us start. It is done. Anything else that is left out? I don't think so. So we are done with it. Let me just change the leaders. Okay. So point A, which is 20 mm above, 15 mm in front of VP, 27 degrees is alpha, no, 27 degrees theta, 37 degrees alpha, 42 degrees is the phi, and 48 degrees is beta. And then we have the true length to be 67 mm, and 50 mm is the front view length, 67 is the true length, 60 is the up true length. Thank you. This was all from my side that I could do today. So thanks for watching.